Good morning, students. We are studying NCERT Class 8 Math Part 1, Chapter number 4, Quadrilaterals. Today is 17 August 2026, and in previous class we have studied about the rhombus and its properties. In today's class we will study about the kite and trapezium. Now this was the diagram which we were studying in the last class. What we have seen that these are the two triangles, and we have uh, uh, they, these two triangles are with the sides 6, 9 and 12, 6, 9 and 12, and we have just joined the side longer side which is of 12, and we see what is the figure. We see that when this figure is joined, we see these two sides are equal and these two sides are equal, and this figure is a kite. This figure is a kite. Understood? So what is special about this figure that we will see? If we join the other diagonal of the figure, if we join the other diagonal of the figure, and first of all we'll take the two triangles, and what we find out that both triangles are congruent, means triangle DAC is congruent triangle ACB. Why? Because this side is equal to this side is equal to this side, and middle center one is the same side. So by SSS, the triangles are congruent, and in that congruency, what we have concluded that if we mark it as 1, this angle as 2, this angle as 3, and this angle as 4. By corresponding part of congruent triangle, by the corresponding part of the congruent triangle, angle 1 is equal to angle 2, and angle 4 is equal to angle 3. What does it mean? Means that the diagonal is bisecting the angle. Understood? Diagonal AC is bisecting the opposite angle. So in this figure of kite, we can conclude that diagonals are bisecting the angles. Diagonal bisect the angles. Understood? So till now, this is what we have concluded from this figure of kite, that these angles are equal, and when we draw this diagonal, they are bisecting the angles. Means angle 1 is equal to angle 2, and in this diagram, and angle 4 is equal to angle 3. See, now what about this angle? I mean, this is the point O, and what is the conclusion that when the two diagonals are intersecting each other, so what is the angle between them, that we will see. Now see, if we take triangle DOB and AOB, triangle DOB and triangle AOB. Understood? What we see? Angle 1 is equal to angle 2. Understood? AO is common. AO is equal to AO and DA is equal to AB. DA is equal to AB. So we proved that by SSA criterion both triangles are congruent, means triangle DOA is congruent triangle AOB, and since these triangles are congruent, we can conclude that since these are the corresponding parts of the congruent triangle, if we name it as 5 and 6, and so angle 5, angle 6 is equal to angle 5 by corresponding part of congruent triangle. Understood? And since they are in a straight line, so the sum is 180 degree, which concludes that means angle 5 plus angle 6 is equal to 180 degree. And when we combine these two statements, we conclude that angle 5 is equal to angle 6 and both angles are equal to 90 degree. What does it mean? It means that the diagonals of the kite intersect each other at 90 degree, or we can say that the diagonals in kite are perpendicular to each other. This is our second conclusion. What was our first conclusion? Our first conclusion was that the one diagonal is bisecting the internal angles. Understood? And the both diagonals, the intersecting points of the both diagonals are perpendicular to each other. Okay, so this is what we have concluded about the kite, and you should keep these points in your mind. Now we will move to the next topic, that is the another type of quadrilateral and the last type of quadrilateral in this chapter which we will study, and that is trapezium. Now see what is trapezium. What is trapezium? A quadrilateral having one set of or opposite sides pair, only one set of opposite sides are parallel, that is trapezium. Means if these two lines are parallel and we simply join these two lines, so this is the figure of trapezium. Understood? This is the definition of trapezium, that only one pair of there is only one pair which is parallel and the other pair are not parallel, and this diagram is trapezium. Understood? So this is the mandatory definition of the trapezium, that we cannot call square, rectangle, rhombus trapezium, because there is two set of parallels lines. and we required for trapezium only one set of parallel line. Understood? We cannot say that as 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 we have seen in the example of the rectangle and the square, we are saying that all the squares are rectangle because all the properties of the rectangle is fulfilled by the square, and in the same way we have seen that all the squares are rhombus because all the properties of the rhombus are shown by the square. But since we can say that it should have one parallel pair in trapezium, so it is the mandatory and compulsory that it should have only one pair of parallel set, then only it will be a trapezium. That's why it is different from square, rectangle, rhombus, because you can argue that it has opposite sides are parallel, means we can call it as also a trapezium. No, that is not trapezium, because it mandatorily it should have only one pair of parallel set. So that figure will become our trapezium. Now we will study about the trapezium. We have two types of trapezium. Understood? One is we call it isosceles trapezium. In isosceles trapezium, what that opposite sides are parallel, but the non-parallel sides are equal. In that case, this trapezium is called isosceles trapezium. Understood? And trapezium in which opposite sides are parallel and non-parallel lines are not equal, it means it is a regular trapezium. Understood? It is not a specific trapezium, it is a regular trapezium. If we extend it like this and we join it like this, then this figure and these two lines are parallel, but these two are not equal, so this is a regular trapezium. Regular trapezium. And this is isosceles trapezium. Understood? Now we will study some properties of the isosceles trapezium. Now see, this is the diagram of isosceles trapezium A, B, C, D. Understood? This is the diagram of isosceles trapezium. What we conclude about these internal angles, since these angles are parallel. Understood? This is our construction which we are constructing actually. This is our construction. Say E and F. Understood? Now, if we take these two triangles, in triangle AED and triangle BCF, what we see that we have drawn this line perpendicular. Understood? We have drawn this line perpendicular, and the distance between two parallel line is always same. So we can say that AE is equal to AF. Why? The distance between two parallel lines, the shortest distance between two parallel line is always same. So that is the actually property of parallel line. and what we see that this angle is equal to this angle because both are 90 degree, means angle E is equal to angle F as both are 90 degree. Also AD is equal to BC. So side angle side criteria or both triangles are congruent. Understood? Means triangle AED congruent, triangle AED congruent triangle BFC, and by corresponding part of congruent triangle angle ADE, angle ADE is equal to angle BCF. This is by corresponding part of congruent triangle. So what we have concluded that this angle is equal to this angle. In the same way, we can prove that this angle is equal to this angle by corresponding part of congruent triangle, and this angle is already 90 degree. Understood? Which is equal. So we can conclude that angle A, sorry, angle BAD is equal to angle ABC. Understood? This is also we have concluded. So what we have concluded in the isosceles trapezium, that angles in same line, opposite angles on same line are equal. Angles on same line are equal. Okay? Opposite angles on same line are equal. This is the conclusion from this our discussion, that in isosceles trapezium angles opposite angles on same line are equal. What we can conclude about regular trapezium? In case suppose this is our regular trapezium, means the non-parallel sides are not equal. Understood? So what we can conclude that since AB is parallel to DC, AB is parallel to DC, that is the mandatory requirement of a trapezium. So we see that angle 1, angle 2, angle 3 and angle 4. What is the relation? We can conclude that angle 1 plus angle 2 is 180 degree, which is the property of a parallel lines and transversal line. Also angle 3 plus angle 4 is equal to 180 degree. Understood? If we have given with the angle 1, we can find out the angle 2, and if we have given the angle 3, we can find out the angle 4, but the relation between them we cannot establish, just because this is not a regular, this is not a isosceles trapezium, this is a regular trapezium. So this is all we have studied about the trapezium. Now in this chapter, our chapter is ended, finished. We have completed all the topics. Now we will see at the end of the chapter what exercises are given. We will solve them one by one. So our first exercise is in page number 107. Find all the angles, find all the sides and angles of a quadrilateral obtained by joining the equilateral triangle with sides 4 centimeter. This exercise we have done already. We have equilateral triangle. You can say that solution 1. We have two equilateral triangle, each having 4 centimeter length, and we are joining it. When we join it, what figure we will get? Suppose we have joined like this. This is 4, 4, 4, 4 and 4. Now they are saying that we have to find out the all angles and sides. So all sides are will remain same. All sides are same and of 4 centimeter. All sides are of equal length, and that is 4 centimeter. Now we will see about the angles. Now what is this angle? What is this angle? This all are the equilateral, both are the equilateral triangle. So all angles are 60 degree. All angles are 60 degree. We see when we have joined, so all angles are 60 degree. Means this is 60, this is 60, this is also 60, this is also 60, this angle is also 60, this angle is also 60. So if we name it A, B, C, D, what we find out that angle D is equal to angle B is equal to 60 degree. Understood? And angle A is equal to angle C, and they are 120 degree. This is our solution of first question. Now we will move to second question. What is our second question? Construct a kite with a diagonal of length 6 centimeter and 8 centimeter. Understood? We have to construct a kite with a diagonal of 6 centimeter and 8 centimeter. In this class only we have studied that the diagonals of a kite are perpendicular to each other. Understood? The diagonals of a kite are perpendicular to each other. So what we will do? First we will draw a 6 centimeter line segment. Understood? With the use of scale. Now find the midpoint. How will you find the midpoint of this line? You can find the midpoint of this line by using your compass, or by just simply you can mark the midpoint. Otherwise, if you use your compass, take radius more than the half of the approximately more than the half of the distance of this line segment. Means it should be more than 3 centimeter, since we know. And actually this is the process which I am telling you, that you can find the midpoint of any line segment without knowing its distance, its length. Understood? You can find out the midpoint of any line segment without knowing its length. So approximately you have taken, when you take the radius more than half of this length, and you mark arc from this end point, and then from this end point you mark arc, and the point where these two arcs are intersecting, you can join. When you join it, the point where these lines are intersecting it, this is the midpoint of this line segment. Now this is the midpoint of this line segment, and also this is perpendicular. Always this is perpendicular. Now since we have to draw a kite, take this radius 6 centimeter. Also mark this radius as here. This is the point you have marked as a 6 centimeter, and from here, since you have marked take this radius as 3 centimeter and mark here, cut, and now this is 3 centimeter. Now what you will do, we have the length 3 centimeter, or now what length left, 8 minus 3, 5 centimeter. Draw a 5 centimeter length up to here, understood, and erase the rest of the part, and with the help of your scale, join the endpoints. Join the endpoints. This is your figure of kite, in which this is DC, means in which your AB is 6 centimeter and DC is 8 centimeter. Understood? So in this way, with the help of your compass and scale, you can draw a kite. Now question number 3, find the remaining angles of the trapezium. So in this question, they have given us one regular trapezium and one isosceles trapezium, and we will find out the other angles. This is your question number 3. In this way, they have given us this angle is 135 and this angle is 105. Understood? You can name it. Now see, when this arrow in figure, they have given arrow like this, it means they are parallel. Understood? So these two are parallel, so we can find this angle. This angle is 180 minus 105. 180 minus 105, and that is 75 degree. Understood? Your angle B is 75 degree, and this angle is 180 minus 135. So your angle A is equal to 45 degree. Understood? 45. And what is our next figure? Next figure is a regular trapezium. Now in this figure, see, they have shown this arrow. This means that they are parallel, and they have just marked these two lines like this, means these two non-parallel lines are equal, and they have given us one angle. This is 100. So what we have seen in the isosceles trapezium, that opposite angles are equal. So this is 100. So this is also 100. Understood? This is also 100, and the sum is 180. So this is 100 minus. Okay, our figure is actually reversed, because this angle is looks like a acute angle, and we are making it as a obtuse angle. So we will reverse the figure as it is shown in the book. Otherwise we can solve it like this also. This is our isosceles trapezium, and this angle is 100. So this angle is also 100, and this angle is 180 minus 100, that comes out to be 80 degree, and this is also, these angles are equal, so this is also 80 degree. So this is our answer. Now we will move to the question number 4. What is question number 4? Draw a Venn diagram showing the set of parallelogram, kite, rhombus, rectangle and square, and answer the following question. Let's draw the Venn diagram. First of all, we will draw the diagram of the, see, suppose this is a set of rhombus and this is a set of rectangle. Understood? This is rhombus, this is rectangle. Then what will be this intersection part? This is square. Understood? Now the third diagram is left, that is kite. Can you say that kite is a rectangle? Can you say kite is a rhombus? Or can you say kite is a square? Can you say all the rectangles are kite? Can you say all the rhombus are kite? Can you say all the squares are kite? Yes. This figure will be like this, that when you extend this figure like this, let me mention it by the different color. This diagram is actually your kite. What does it mean? It means that your all, now see, what we have seen in the rhombus, that diagonals are perpendicular. Understood? And in case of square, diagonals are perpendicular. So, and those rectangles in which the diagonals are perpendicular, they are also a square. So this is the diagram of, and this complete diagram is quadrilateral. This complete set is quadrilateral, and this blue is showing kite, and this inner red, this is showing rhombus, and this part, intersection part, is showing square, and this part is showing rectangle. Now we will see what they have said in the question. What is the quadrilateral that is both kite and a parallelogram? Okay, actually they have said that we have to draw the parallelogram, not quadrilateral. So in case of parallelogram, what we'll see, that rectangle is also a parallelogram, rhombus is also a parallelogram, square is also a parallelogram, but kite is not parallelogram. Kite may be a parallelogram or may not be a parallelogram. So what does that mean? That there are the some kites which are not parallelogram. Understood? So this is figure of our rhombus. This is rectangle, this is square, and I will draw the kite now separately. And this is what? This is actually quadrilateral, of course, but this is the parallelogram. What does it mean? That we have opposites in a rhombus, opposite sides are parallel. We have in a rectangle, opposite sides are parallel. We have in a square, opposite sides are parallel. Understood? But if we extend this figure like this, understood? If we extend this figure like this, means square is also kite, rhombus is also kite, and those rectangles which are square, they are also kite, and this portion is saying that those which are not rhombus, those which are not square, but they are kite. Understood? This element. So this is the diagram of the parallelogram, kite, rhombus, square and rectangle. This is a Venn diagram, required Venn diagram. Now we will see. Now they are saying what is the quadrilateral that is both kite and a parallelogram. Matlab, we have to say what are the those diagrams which are both parallelogram and kite. So we see the point of intersection of kite and parallelogram. So this is the point of intersection. This is the area of intersection. So what we will see that rhombus and square is the answer. So rhombus and squares are the parallelogram which are kite also. Answer number 1 is what? Answer number 1 is rhombus and square. Understood? Let's see what is the question number 2. Can there be a quadrilateral that is both kite and rectangle? Can there be a quadrilateral that is both kite and rectangle? Yes, we can see in this diagram. This is a rectangle and this is kite also. And but what is this actually? This is square. So answer number 2 is R square. Answer 2 is square. Answer 2 is square. So square is that diagram which is kite as well as rectangle. Understood? Answer 2 is square because square is rectangle as well as kite also. Now what is question number 3? Is every kite is a rhombus? If not, what is the correct relationship between the two types of the quadrilateral? Understood? Now they are saying that every kite is rhombus. No, the kite which are not parallelogram, they are not rhombus. So what is the relation between the kite and the rhombus? Only those, means all the rhombus are kite, but not all the kites are rhombus. This is the relation. Means when the perpendiculars are when the diagonals are perpendicular in case of kite, and they are bisecting each other. Understood? That is the case of the rhombus. That is the case of rhombus, and only that type of rhombus, that only that type of kite is rhombus. That is the relation. I will explain this. And that is also a square also. Now see, this is our rhombus and this is our kite. Understood? In kite we have diagonals perpendicular, and in rhombus also we have diagonals perpendicular. So only those kites which have all the sides equal, only those kites which have all the sides are equal, they are rhombus. Means only those kites whose diagonals bisect each other and perpendicular to each other, they are actually rhombus. So this is the relation between kite and rhombus, and we have also seen in the Venn diagram also. Now we will move to the question number 5, and in this class we will do up to the question number 5, and then rest of the questions we will do in the next class tomorrow. What is our question number 5? They have given us two rectangles. This is one rectangle, that is PAIR. PAIR. And we have another rectangle, RODS. RODS. We have another rectangle. Now this angle they have given us, this is 30 degree, and we have to find the angle IOD. Angle IOD. We have to find this angle. So what is this angle? It is very easy to calculate. How we will calculate this angle? Now see, SROD is a rectangle, so angle ROD, angle ROD is 90 degree. All the angles in the rectangle are 90 degree. Understood? Now angle RIO is 90 degree. 90 degree. Angle RIO is 90 degree, and this is 30 degree. So this angle is 90 plus 30. 180 minus 90 plus 30 means angle ROI. Angle ROI is equal to 180 minus 90 plus 30, that is 60 degree. Understood? So this angle is 60 degree, and now this complete angle is 90 degree. So angle IOD equal to 90 minus angle ROI, that is 90 minus 60, that is 30 degree. Understood? So this angle is also 30 degree. Understood? In this way we have find out this angle. So this is all about today's class. Today we have finished kite and trapezium and the few problems which are given at the end of your chapter. Rest of the problems we will do in the tomorrow's class. Till then, take care and thank you very much.